Viewers, welcome back to Sciencing Around, and now I'm gonna cover the topic named as the thermal expansion, as you can see in the notes. Let's let's start now. Come on, I don't have to. You don't have to waste your time, of course. So let's do it. Here you can see in my notes that there are types of expansions at delta t. Here don't say small t is changing time because this is thermal expansion, so small t is changing temperature right here. So linear expansion at first. Now you must have a question, what is linear expansion? At least some people who are viewing this video. So now listen to me. Now most of the things are based on listening. So now suppose that I have a line or a rod, a very exceptionally thin rod of length, which is L. Let the rod length be L. I heat it at the temperature delta T. Then what happens on the rod is the rod expands. Now why does thermal expansion happens? This is because the electrons becomes loose, tries to vibrate much as the temperature increases. They try to lose their metallic body, and thus tensile stress, I must say, is applied on that metal, which encourages the metal to expand. So this is nothing but L, and this part which is expanded is delta L heated to delta T. So its formula would be delta L equals to L naught into alpha delta T, where alpha is coefficient of expansion for, or we must say alpha is coefficient of linear expansion, as alpha is only for linear objects, that is one-dimensional objects. Now we have aerial expansion right here. What is aerial expansion? If you would visualize, it would be better. I'm heating this part, this whole sheet, and it is expanding like this. This is the expanded part, the dotted ones. Means this is area of original sheet, and area and this is delta A, which is the change in area, or if this is area, if this is A naught, then A naught minus A is the delta A, which is delta A equals to A naught into beta delta T. So A naught should be this, and this should be A1, suppose anything. So delta A equals to A naught into beta delta T, where beta is the coefficient of aerial expansion or superficial expansion, as it is as it relates to only two-dimensional objects. And now we have volume expansion. Volume expansion has coefficient gamma. Now what is volume expansion? If my diagram looks bad, then please, I'm sorry, because I'm not good at drawing, honestly. I'm trying to draw a cube. Now suppose it's a cube, it has a volume V, and we heat it. It becomes the whole cube, the volume of the cube expands. Expands to some of its original volume, from its original volume. That is V, and expanded one is delta V. So as the formula, delta V equals to V naught into gamma delta T, where gamma is the coefficient of volume expansion. So delta L equals to L naught alpha delta T, delta A equals to A naught into beta delta T, and delta V equals to V naught into gamma delta T. And now below you can see the relation between alpha, beta, and gamma, where beta equals to 2 times alpha, gamma equals to 3 times alpha, and of course 2 beta equals to 3 gamma. And of course for anisotropic solids, beta would be the summation of alpha, where alpha 1 plus alpha 2, since beta equals to 2 alpha, and gamma would be alpha 1 plus alpha 2 plus alpha 3, since gamma equals 3 alpha. Now moving on, next, expansion of liquids in a container. Now here I have made a diagram for you. Here you can see gamma L is the coefficient of volume expansion of liquid, and gamma C is coefficient of volume expansion of the container. And the container is filled full with liquid with the whole upper height, with the full height of container. Then what would be the expansion, or what do we say, what would be the expansion of liquid? Yeah, delta V equals to V naught. Delta V is the volume or container volume. Delta V equals to V naught into gamma liquid minus gamma container into change in temperature. Delta V equals to V naught gamma delta T, where gamma equals to the gamma L minus gamma C. So that's it. And now expansion in radius, I'm sorry. We have a ring having its inner and outer radius. We hit that. There must be some difference between those. So expansion in that thing would be R equals to R naught into 1 plus alpha delta T. I hope it's quite easy to remember these formulas, as you have to derive other words. Otherwise you have to derive these things in the exams where you'll face it. So I think you should learn these things. Now what is thermal stress? Now the thermal stress tells me that, now see, here you can see two rigid walls, and a rod is placed, and the walls are applying normal force on the wall, that is F. F from this side, F on this side. L naught is the length of the rod, and F is the force where walls are applying to the rod. Then if we heat this rod, then the rod will of course try to expand, and whenever the rod would try to expand, it would apply a force on the wall. What would be that force? By Young's modulus we have just derived the force. Like we know y equals to FL upon A del L. We know L naught upon del L by the above formulas, where L naught upon del L equals to 1 upon alpha delta theta. So upon again those rearrangements and all that stuff, force equals to YA alpha dt, where dt is change in temperature. So F equals to YA alpha mod of gt, where mod is always positive, so change in temperature would always become positive. So F equals to YA delta L upon L naught, since alpha del T equals to delta L upon L naught, and all that. So I hope we completed with this page. Let's get on next. Now here we'll look what we have. We have variation of time in pendulum clock. Now suppose we have a pendulum clock which is in a certain room temperature, and if we heat that, then the pendulum would be expanded. That would definitely affect its oscillation and its time period, and we would have change in its time, where delta capital T is time here. So delta T upon T naught equals to half of alpha delta T. That's the simple formula, like delta L equals to L naught into alpha delta T. Here delta T equals to T naught into alpha delta T divided by 2. That's the variation of time. That means the clock would differ by this time if we would increase or decrease the temperature. That would be, sign could be decided by the temperatures. And now the one of the most important part of heat, that is the calorimetry. Now what does this thing tells us? That the first thing we have is the specific heat. What is specific heat? As you can see, I created these notes a week ago. I wrote it: the amount of heat required to increase the temperature by 1 degree Celsius or 1 Kelvin for unit mass. So no need to explain, it's simply an explanation. So dq is the amount of heat. dq equals to mc dt. dq is change in amount of heat, so q equals to m is constant, goes out, m into integral of c dt, where this is t2 and this is t1, that is its limits ranging from temperatures initial to final. C is specific heat. As you can see here, when it differs from compound to compound, for water C is 1. And now let's get to the latent heat. We are going quite fast, aren't we? So latent heat, the heat required to change the phase, that is the heat required to change from water to water vapor, or from, we should say, ice to water, or anything like that. So Q equals to ml. Q is the heat, and L is the, actually L is again a constant, that is that varies for compound to compound. That is for ice it's 80, for steam it's 540, as you can see written here. Q equals to ml, and L equals to cdt. That means Q equals to mcdt if we equate these two. That's all we have. And now molar heat capacity, that is the heat capacity stored in 1 moles of any compound. That is C equals to Q upon nu dt. That is nu equals to mass into, what do we say, mass into the specific heat. So thermal capacity would be Q upon dt. And what would be water equivalent? The equivalent of any compound related to the water would be water equivalent, and it would be mcg. I never ever heard a question on this thing before, but since this thing was famous in the internet, other blogging sites, so water equivalence equals to mass into specific heat into G. You know what's G, of course. Gravity, come on. So guys, I believe that was okay for now. Should we recap? Okay, let's. Heat and thermodynamics. First comes the thermal expansion. The formulas were delta L equals to L naught alpha delta T, delta A equals to A naught gamma delta T, delta V equals to V naught gamma delta T, delta A equals to A naught beta delta T, and delta V equals to V naught gamma delta T, where length, its area, and its volume would expand in the three respectively. The relation between beta and alpha, also expansion of liquids in a container, that is, if the liquid is if the container is filled full of liquid, if we heat that, then what would be the expansion of liquid? We can just use this formula to calculate how much liquid falls away from the container, or how much liquid goes down of the container, and all that thing. That depends on the gamma of both, if your brains, of course. And expansions in radius, r equals to r naught into 1 plus alpha delta T. Thermal stress, the rods are kept between two walls, the rod is heated, it would expand and create a stress on the walls. That would be F equals to YA alpha delta theta and nothing else. Now going ours next, that comes variation of time in pendulum clock. Simply formulas. The calorimetry where specific heat required to increase the temperature by 1 degree Celsius, dq equals to mc dt, q equals to m integral of c dt, where c is constant and c is specific heat, and it differs for various compounds to compounds. Where latent heat required to change the phase, q equals to ml, where l equals to c dt. Molar heat capacity comes where c equals to q upon nu dt. Thermal capacity where q upon dt. Water equivalent mcg. So guys, thanks for watching. I hope you like this video. If you would find this video quite informative, then please press that like button, because I want your support. And of course, don't forget to subscribe the video, because I want to upload more for you. I want to do something for you. I want to be something, actually. So thanks for watching, and don't forget to leave the comment of what type of video do you want, or in what style should I change to entertain you. Like, what should I change myself? How should I change myself to earn your subscription? So thanks guys, see you next time. Next time I will deal with kinetic theory of gases. Thanks for watching. Goodbye.